So now, in this video, we're going to graph an inequality. The inequality I've chosen is 2y minus 3x is greater than negative 4. Okay, so the first thing we need to do to graph this, well, let's describe the whole procedure. Look at this. For graphing a linear inequality, first we graph the boundary line for the inequality by changing the inequality sign to an equal sign, then graphing this equation. Make it a dashed line if the inequality sign is less than or greater than, and a solid line if it is less than or equal to or greater than or equal to. Then, once the boundary is drawn, choose a point off of the line on one side or the other as a test point. Substitute these values in for x and y in the original inequality. And step 3, if the test point makes the inequality true, shade all of the area in the side on that side of the line, and if it makes a false statement, shade the other side. Okay? So that's what we're going to do. First, we're going to change this to an equation. 2y minus 3x is equal to negative 4. That's a linear equation. We can graph a line, and we've done that in previous sections. So, let me make that x a little better. Okay, so what do we do to graph this? We put it in y equals mx plus b form. That's the slope-intercept form. Let's write that down. Our target is y equals mx plus b. And again, that's the slope-intercept form. Okay? So we need to make this look like that. So what do we do first? To isolate y, we remove the x term by adding it to the other side. I'm going to add 3x on this side and this side. And remember, since we're looking for mx plus b, we want to write this side in that form. So I have 2y on this side. This 3x and the negative 3x have added to 0 or canceled. And on this side, I'm going to have 3x minus 4. Make sure you put it in that order. Don't put the 4 first, even though it's on top. And now we still want to isolate y, have y by itself. So I'm going to divide by 2 in each part of that equation for each term. And now I have that form y equals mx plus b. Y equals negative 3 halves x minus 2. Okay? Now it's in slope-intercept form. We can pick out the slope and the y-coordinate of the y-intercept and use those to graph it. Remember, the step said if it's greater than or less than, we're going to use a dashed line or a dotted line. If that was less than or equal to or greater than or equal to, we would use a solid line, indicating that those points on the line also satisfy the equation, the inequality rather. Okay, so what is the y-intercept? Since b is negative 2, that would be 0, negative 2. It's a point. Let me start with that as an anchor, as a place we know the line exists. So we'll put that point there. Okay? And now we're going to use the slope. We can pick out the slope. That's the m in the m position in that form. 3 halves. And remember, that's rise over run. Okay, so we rise in the y direction 3 units from here. 1, 2, 3 units, and then run in the x direction, positive 2 units. If it was negative, it would slope that way, but this one is sloping that way. And now we have 2 points, we can draw that line. So let me do this carefully. Maybe I should do it on this side here. Okay? So we have our dotted line. It's dotted again because this says greater than. If there was an equal to sign as well, we'd use less than. Now, we're going to do the third step, pick a test point. We can choose any point that's not on this line to see whether this side has all the values that satisfy that, or this side. A convenient one for most equations, and most inequalities, is this point 0, 0, the origin. So we're going to plug that in the original equation. 2 times 0 plus 3 times 0 is greater than negative 4. And I'll put zeros in there in a different color so we know we inserted something. Right? And if we calculate that, 2 times 0 is 0, minus 3 times 0, which is also 0, gives us 0. And our question is that greater than negative 4? Well, yes, 0 is a larger number. It's to the right on the number line of negative 4. So that's true. Since that's true, we're going to shade the side of the line that has 0, 0 in it. And what that means is this side that's shaded contains any point that if we plug it into this equation will make it true. Any point on this side will make it false. And there's a graph of that linear inequality.